Welcome back to the tutorial review part 2. In this example, we want to look at horizontal and vertical asymptotes of function. Stay blessed. Now, we are asked to find the horizontal and vertical asymptotes of this function f of x is equal to minus 2 all over x minus 5. Now, to find the horizontal asymptotes, what do you mean by horizontal asymptotes? Just like if you have a function, let's say we have this, we have a graph, the horizontal asymptotes is that particular line that is parallel to x-axis. X is always on the horizontal axis, so the line that is parallel to it is what we call the horizontal asymptotes. While the one that is parallel to y-axis is called, this is the vertical asymptotes. This is the horizontal asymptotes. Okay, so that is that about that. And so when we are talking about horizontal asymptotes, we are talking about the value of y. When we are talking about vertical asymptotes, we are talking about the value of x, because the vertical asymptotes is found here. The horizontal asymptotes is found along this line. Okay, now that is that about that. Now, how do we practically find this? Okay, now we look at the degree of the denominator and numerator. We check the degree of the numerator and denominator, okay, to find the horizontal asymptotes. Clearly here, the degree of numerator is 0 because numerator does not have any degree. Clearly, minus 2 is in the numerator, so which is a constant, so it does not have a degree because it is a constant. Minus 2 is a constant. Why? The value in the denominator is s minus 5 is the denominator. So the degree of x there is 1. So the degree of x here is 1. Since the degree of denominator is more than the degree of, because the numerator does not have any degree, so we assume it's 0. But the degree of denominator is more, which is 1, than the degree of numerator. That means the horizontal asymptotes y is equal to 0. So, since the degree, now conclude that since the degree of the denominator is more, than the degree of the degree of since the degree of the denominator is more than that of numerator, hence the vertical asymptote y, the horizontal asymptote y, the horizontal asymptotes y equals to 0. But if the degree of denominator is more than that of numerator, we are going to have what we call oblique asymptotes. Oblique asymptotes. And in that case, we have to divide through. We divide the numerator by the denominator in order to factor out the asymptotes. Now, we have gotten the horizontal asymptotes. How do we get the vertical asymptotes? That's very simple. Just equate your denominator to 0. To get the vertical asymptotes, that is the y, we equate x minus 5 to 0. That is, x minus 5 equals to 0, so x equals to 5. So therefore we conclude that Now we conclude that. Now we conclude that y, which is the horizontal asymptote, is 0, while x, which is the vertical asymptote, is 5. That is that about that. Now let's look at some more examples. Let's look at more examples. Let's look at more examples. This is another interesting example. This is another interesting example. Let us use a better marker that will not deface the board. So let's say example 2. This is not good. Let's look at another marker. Example 2. Yes, I think this is better. This is better. Given that f of x is equal to 2 plus epsilon, exponent, at this, given that f of x is equal to 2 plus exponential raised to power minus x, find the horizontal asymptotes. Find horizontal asymptotes. Want to find exponential raised to power minus x, 2 plus exponential raised to power minus x. Find the horizontal asymptotes. Note first that horizontal asymptotes is talking about what? It's talking about the value of y. While the vertical asymptote is talking about the value of x. Now, for us to do this, the very first thing we need to do is to take the limits. Yes, to find the horizontal asymptotes, that's we want to find the behavior of this function as s tends to plus or minus infinity. We find the behavior. We want to find the behavior of f of x as x tends to plus or minus infinity for us to find the horizontal asymptotes. This is not a rational number. I mean, it's not a rational function. You can see 2 plus exponential raised to minus x. So it's not rational. It's an exponential function. And for us to do that, that means we have to find when we take the limit when s tends to infinity and when x tends to minus infinity. So taking limits as s tends to plus infinity, that is how we have what? 2, that is limit of 2 plus exponential minus x. That what? 2 plus exponential minus infinity. Just like saying that, generally, when your x tends to infinity, so exponential raised to power minus x will be 0. So 2 plus 0. So this is 2. Okay? That is going to be 2. Now, as x tends to limit, as x now tends to minus infinity, of 2 plus exponential, this one will now become plus. Okay? Now, you observe that this value will become large and large and large. So, this one will be 2 plus infinity. Because exponential raised by infinity will give us a very, very big value. So, and then adding 2 plus infinity, you have infinity. Because any number you add infinity to, we always give you what? We always give you infinity. Okay? So, now, the behavior of these asymptotes is that the horizontal asymptotes will be equal to 2 and infinity. So the range is 2. So let's write it this way. So the horizontal asymptote is so the horizontal asymptotes now. Therefore, so we can now say that let's clean it. And you know infinity is not definite. So the horizontal asymptotes y, is greater than or equal to 2. I think that's the best, because we obtain 2, we have infinity. So the horizontal asymptote is y greater than or equals to 2, because at a point you get 2, the other one gets infinity. So it will be greater than or equal to 2. Now, the next question. This is still talking about. This is a beautiful one that explain more on the degree of numerator and denominator as regards horizontal asymptotes. Let's quickly do this. This is an example 3. Example 3. Consider f of x equal to x squared. Yes. All over x plus 1. Beautiful. Find the horizontal asymptotes. Yes. Find the horizontal asymptotes. Find the horizontal asymptotes. Okay. To find the horizontal asymptotes here, as we have been told, we just need to find the degree of denominator and numerator. The degree of numerator here is 2. That of denominator is 1. So the degree of numerator is more than that of this is going to have another version of asymptotes. It's going to have what we call oblique asymptotes. Oblique. So anytime the degree of numerator is more than the degree of denominator, it will have no horizontal asymptotes. Rather, it's going to have what we call oblique. Oblique. Why? Why will it be oblique? Because the asymptote is not direct. So we have to obtain it by using long division. Yes, it's not direct. It should have been direct if vice versa, if the degree of numerator is smaller than that of denominator. Because we can't divide. We can't carry out division there. But this one now, it will give us a mixed fraction. Let's see. Let's carry out the division. X squared, x plus 1. So x in x squared, that's x. Multiply x by x plus 1, x squared plus x. Now subtract, this one will change to minus. I now have what? Minus x. Now again, divide x by minus x. Minus x by x, that's minus 1. Multiply minus 1 by x plus 1, that's minus x minus 1. So by the time you introduce minus again, this one becomes plus, this one becomes plus. So we have plus 1 left, which implies that our result is now what? X minus 1 plus 1 all over x plus 1. Now, this x, 1 over x plus 1, if you take its limit, it's going to tend to infinity, obviously. Note, 1 over x plus 1 tends to infinity as x tends to, tends to 0 as x tends to infinity. The whole of this value. You are asking me why. 1 over x plus 1, if you take x to be tends to infinity, this one could be, this is less than 1 over x. 1 over x plus 1 is less than 1 over x. Do you agree with me? Yeah. Okay, so if by the time I say, let x tends to infinity of 1 over x, that's 1 over infinity, which is 0. You know that. So the whole of this is 0. Because 1 over x plus 1 is bounded by 1 over x. Don't be funny. Don't be surprised. If our x is 1 here, that will be 1 over 1 plus 1, that's 1 over 2. 1 over 2 is less than 1 over 1, which is 1. Yes? If our x is 2 here, that will be 1 over 2 plus 1, 1 over 3. It will be less than 1 over 2. So 1 over x plus 1 will always be less than 1 over x. So it's bounded. So that's it. So in this case now, since the whole of this is 0, then our horizontal asymptotes now will be the linear value that we obtain here. So the oblique, therefore, hence, the oblique asymptotes is now what? Is x minus 1. That is the answer. That's it. Let's say is y equals to, is y equals to x minus 1. That's it. Now, let's look at one other more question One more question. It seems this video will still be extended to part 3. Yes, because the review is really much and we have to carry them out so as to enhance your performance in the subsequent assessments, whether test or examination or what have you. These are just the review questions on what we have learned previously. Now, given that, let's like this. Given, I think this is number 4. This is number 4, example 4. Given that theta, this is coming from trigonometry, is an acute angle, and sec theta is 3 all over 2. Find, without using a calculator or 4-figure table, the value of 1 tan theta, 2 cosec 90 minus theta, respectively. Cosec 90 minus theta, respectively. Now, how do we solve this? This question is coming from trigonometry. If theta is an acute angle, and what is an acute angle? An acute angle is an angle that is less than 90 degrees, but is greater than 0. And sec theta is 3 over 2. Find, without using a calculator or 4-figure tables, the value of 1 tan theta, 2 cosec 90 minus theta, respectively. Okay? Now, the very first thing we need to do for us to be able to get tan theta is we have to interpret tan theta with respect to sec theta. If you are able to do that, it will be easier for us to do. Okay? Now, recall, is there any identity that combines tan theta and sec theta together? Yes. Recall, 1 plus tan square theta is equal to sec square theta. Beautiful. Yes. So from here, for us to get tan theta, it will not be difficult again. So you can say tan square theta now will be sec square theta minus 1. Yes. Okay. Now, how do we now get tan theta? Because we are looking for tan theta. Find the square root of both sides. So, therefore, tan theta will be square root of sec square theta minus 1. Beautiful. Beautiful. So, what we just need to do is now to substitute. Then what? Tan theta now will be square root of, if sec theta is 3 over 2, sec square theta will be what? 3 all over 2 squared minus 1. Beautiful. Beautiful. So we are almost there. We are almost there. So that means tan theta now will be square root of 9 all over 4 minus 1. That will be square root of LCM is 4. 1 here is like 1 over 1. So 4 in 4, 1 times 9. 9 minus 1 in 4, 4 times 1, 4. So we have square root of 5 all over 4, which is the same thing as square root of 5 all over square root of 4. So we can have this as the square root of 5 all over square root, over 2, because square root of 4 is 2. So tan theta is 5 over 2. As simple as that. It's as simple as that. Now what about cosec, 90 degree minus theta. Now, cosec 90 degree minus theta. From co-function, you can remember from cofinite function, recall, from co-function. Cosec 90 minus theta is equals to sec theta. Sec 90 minus theta is equal to cosec theta. You must know this offhand. These are co-function in trigonometry. There are many of them like that. You can take notes. Then tan 90 degree minus theta is equal to cot theta. Cot 90 degree minus theta is equal to tan theta, and so on and so forth. I hope you know the other one for sine. Sine 90 minus theta is cos theta. Cos 90 minus theta is sine theta. So you can memorize that. Now, since what we are finding is cosec 90 minus theta, which is the first one, therefore cosec 90 minus theta, which is what? Sec theta, will now be what? And what are we given for our sec theta as according to the question? 3/2. So we don't need to really stress ourselves here. From that cofinite function or for cofunction, cosec 90 minus theta is sec theta. And as given in the question, sec theta is 3/2. So with this, we have come to the end of the second tutorial review video. So do well to click on the notification bell so that in the third video, you'll be duly notified. Thank you.